Now we are taking up the topic matter and its composition, and before we do that we should know what actually the matter is. Matter is anything that occupies space and has mass is called as matter. If anything which we use occupies space, that means it has certain volume, and mass means it has the quantity of matter in it. So anything which you come across which has space, when you keep it, it occupies space and it has mass also, is called as matter. For example, this marker, if I keep it, it will occupy space and also it has certain mass also. So it is also a form of matter. Matter is now formed of three kind of particles. The particles can be atom, it can be molecule, it can be ion. So we'll be taking these terms in detail later, but for this moment I want you to know them in brief, what actually these are. Atom is the smallest particle which does not exist independently. It does not exist independently. I am repeating it, keep in mind, atom does not exist independently. And molecule is actually formed by the combination of atoms. When two or more atoms combine, they unite, they form a chemical bond and they form a molecule. For example, CO2. See, in CO2 there is one carbon atom and there is two oxygen atoms. So that means three atoms are just combining, they are linking by chemical bond and they form a molecule. And now what is ion? See, atom as a whole is actually a neutral. We'll be studying it later on. The atom consists of three kinds of particles: proton, electron and neutron. Proton positively charged, electron negatively charged, and neutron has no charge. So in atom is electrically neutral because the number of positive charges is equal to the number of negative charges. But whenever it undergoes a change in which electrons are lost or electrons are gained, it does not remain neutral. It does not remain atom. It becomes ion. It becomes ion. So that means atom which bears a charge, whether positive or negative, it is called as ion. So matter can be formed of any of three. It can be formed of atoms, it can be formed of molecule, it can be formed of ion. So these are the three constituents of matter. Now the question comes, how we can feel the matter? So matter can be perceived by any of the physical senses like touch, smell, any of the senses. By the physical senses we can feel the matter. And now the question comes, what does it comprise of? Matter comprises of living and non-living matter. Matter comprises of living and non-living matter. So now you are familiar with what the matter actually is. What is the composition of matter? What does it comprise of? So we know what the matter is now. Now in the next step we are going to classify the matter. So when we classify the matter, we classify it under two categories. See, we can classify it under two categories, that is physical classification and chemical classification. When I talk about physical classification, that means we have the different physical states that exist in which the matter can exist. So the three physical states which we have studied in previous classes also, that is solid, liquid and gas. As you all have studied only three states of physical classification of matter, but you will be shocked to know there are actually 7 classes of matter which you are going to study in the higher class. So I will list for you those other classes apart from these three: solid, liquid, gas, plasma, BEC, colloidal state, Fermi condensate. So actually there are 7 states of matter, but in the previous classes you are only familiar with the 3 states: solid, liquid, gas, and these states also you will be taking in the higher class. But for your knowledge I am telling you that the matter exists actually in the 7 states of matter. But in daily routine life we come across only 3 states, that is solid, liquid and gas. Now what is the difference between the solid, liquid and gas? Or do you have any example in your mind? Have you seen any solid substance? Can you tell me an example? Okay, I'll take an example for you. See, you must have seen ice. You must have seen the marker, or you must have seen a chair. So these all come under the category of solid. And when we talk about liquid, liquid means water, milk. These all comes under the category of liquid, and gases like nitrogen gas, oxygen gas, air, everything that comes under the category of gas. Now the question comes, what is the difference? What actually they have, that some certain substance only exist as solid, some exist only as liquid and some exist as gas. Like you cannot have O2 in solid form. Do you have O2 in solid form? No. You get O2 only in a gaseous form. Similarly, water occurs in 3 states. It occurs in ice also, it occurs in liquid state also, it occurs in vapor state also. So that means we have different substances which can either occur in 2 states, or they occur in fixed 1 state, or they can occur in 3 of the states. So we should know that what is the difference between these states, that why we call ice as solid, or water as liquid, or vapor as gas. Though it is formed of the same component H2O. You know, water is formed of the same component H2O. It contains 2 hydrogen atom and 1 oxygen atom, but still it exists in different states. If it exists as ice, you say it is a solid. Water is in solid form. If it exists in water, you say it is a liquid form of water. When it exists as vapor, you say it is a gaseous form. So I want you to know that what actually the difference between the solid, liquid and gases. So I will list it for you. So just look at the board carefully. See, in solid, for example, I take an example of ice, or I take an example of wooden block. So in both of them, we see they have definite shape, they have definite volume, they have definite mass. You cannot compress it. What do you mean by compress? Compress means you cannot make the particle come closer to each other. The particles, you cannot make the particles to move much closer to each other. So that means they are almost incompressible solids. We'll be doing it later, that why they can't be compressed and what is the factor that governs the compressibility. And more, they have definite shape, volume, definite mass. We cannot compress it, and also they have high densities. So these are the properties which we get to see in a solid substance. If any substance fulfill these 5 properties, that means it exists as solid. The existence of that substance is solid at room temperature. And when we take up liquid, then what are the factors which govern the substance to exist as liquid? They have definite volume. They again same as solid, they have definite mass, but they don't have definite shape. They take the shape of the container. For example, if you put the water in a tall tumbler, the shape of the water will be like that. If you place it in a wide vase or something like that, it will acquire the shape like that. So liquid takes the shape of the container in which you keep it. And when we talk about the compressibility, they have little compressibility, and the factor which is responsible, we'll be taking it later on. As I've told you, the compressibility factor is governed at the molecular level. We'll be doing it in the next topic. So for this moment, you should know that it is little compressible and it is almost incompressible, and they have less density as compared to solid. So any substance which fulfill these 5 properties exists as liquid at room temperature. And when we talk about gas, then gas does not have definite shape, it does not have definite volume, it does not have definite mass, but it is much compressible. Out of solid, liquid and gas, it is much compressible, but its density is least. So these are the three you can say the factors that govern the existence of substance as solid, liquid or gas. Now I want you to know not much about these terms, but at least you should know what exactly it is. Plasma. Plasma is the 4th state. How you can get it? When you superheat the gas. See, in gas the particles are almost far apart. When you superheat the gas, When the gas is superheated, the ions, electrons, everything, they move out and the charged particle starts moving. That is called the plasma. The plasma is the superheated gaseous state. And when we take BEC, BEC is supercooled solid. So the plasma comes after the gas and the BEC comes before the solid, because when you will supercool the solid, then the particles will unite to form a single substance. They will condense into a single atom. See, in solid, I have told you, particles are very close to each other. When we will supercool it, that means they will unite, they will lose their identity, and they will combine to condense to form a single substance, single atom, you can say. So it is BEC. So BEC is a state which is achieved by supercooling solid. And in gas, as I have told you, particles are far apart. So in plasma, when you heat it, then the particles, at the gaseous level, there are the gaseous particles which are far apart. But in plasma, the electron, protons, charged particle comes out of atom and they are randomly moving. So this is the plasma state, which is achieved by superheating the gaseous state. So these are the states of the matter classification on the basis of physical classification. So matter is classified on the basis of physical classification. Again, I am repeating it for you. Solid, liquid, gas, the properties I have told you, and the other states, plasma, BEC, colloidal and Fermi condensate. So these are the physical classification. One more thing I want you to know, we often use word vapor and gas. We don't know actually what the difference is between the vapor and gas. Sometimes somebody is using for O2, it is a gas. Sometimes you are using O2, vapor is there. But there is a difference between the vapor and the gas. Now what is that difference? Now see, substance is said to be gas which exists as gas at room temperature. For example, if I take O2 sample here, where we are teaching, if we take the O2 sample here means it is at room temperature, no external condition is here. We are not heating anything, we are not applying pressure or anything. It is the normal room temperature conditions and normal pressure conditions. So when we are taking that gaseous sample at this condition, so thus O2 will exist as gas only. So when any substance exists as gas at room temperature, it is said to be gas. But when we take into account vapor, so what actually the vapor is? Suppose if I take a glass of water or a sample of water at this same condition, room temperature and room pressure. So what will happen? You will get to see water in a liquid state. If it will not exist in a gaseous state, it will exist in a liquid state. So that means its actual state is, the vapor is a gaseous state, but at room temperature it exists as liquid. So we call, what is the difference between gas and vapor? Gas exists as gas at room temperature and vapor exists as liquid at room temperature. But when you heat that liquid above room temperature, it exists as in a gaseous form, that gaseous form is called as vapor. So there is a huge difference between vapor and gas. Both terms sound to be same, but actually they are different. So I'll repeat again for you, gas exists as gas at room temperature and vapor exists as liquid at room temperature. But when you increase that temperature, it becomes convert into gaseous state, and that gaseous state is called as vapor. Suppose we are taking an example of ammonia. So ammonia exists as gas at room temperature. If I'll take a sample of ammonia at room temperature, it will exist as gas. But when I will heat it, we'll get to see ammonia vapor. So that means otherwise it exists as liquid. I have used the term ammonia, but for example, we take an example of water. So if we'll take a water gaseous state, at room temperature, it will exist as liquid. But when we will heat it, it will exist in a gaseous state. So it is called as water vapor. That means otherwise the existence is liquid, but above room temperature it exists as vapor.